Hello, let's do some application problems. Find the slope or grade of the treadmill shown to the right. Okay. The slope, that is the grade, is given as a percent. So notice what the answer is. We're going to try to get that answer. Here you've got a right triangle. This is called the rise. This side right here, this is called the run. Slope equals rise over run. Okay, so let's do that. Um, 0.1 over 2. Let's see what we get. 0.1 divided by 2. Not times 2. Divided by 2 is 0.05. That's a decimal. We have to turn the decimal into a percent. You do that by multiplying this decimal by 100%. 100% is really 1. So you're just multiplying by 1. You haven't really changed anything. But you have changed the form. Multiplying by 100 moves the decimal point to the right 2 places. Or you can just multiply 0.05 by 100. And you get 5. So 5%. This is a 5% grade. Not a grade you would want, but a good grade, I guess, for a treadmill. Now it says find the slope or the pitch of a roof. We're going to give that answer in percent also. Notice it says here are instructions, and on MyMathLab, they're in blue. Round to the nearest percent as needed. Okay, I'll do that. I am going to take the rise over the run. Here's the rise. Here's the run. Rise over run equals 1.7 over 5. I'm going to put that in the calculator. 1.7 divided by 5 is 0.34. We're going to do just what we did last time. To change 0.34 to a percent, we multiply 0.34 by 100%, and that will give us 34%. Now notice the percent sign is supplied for you, so don't say 34% in the answer box, which is also blue. Okay, this is a blue answer box, and these are blue instructions on how to answer. All right, now we're going to talk about rate of change. And that's probably the most important use of slope. Find the rate of change in luxury purchases in a certain country with respect to time in years. What that means is how much are the purchases going up in dollars or in billions of dollars per year, every year? Well, let's find out. Here, notice we're given data points. We're given the year and the amount of the purchases in billions of dollars. So we could make this X1 and Y1 and X2 and Y2. I have to turn my phone off, or at least put it in silent mode. Actually, the real truth is I'm going to put it in airplane mode. Thank you. Now, hopefully that'll work. Okay, let me go back to black here. M equals Y2 minus Y1 over X2 minus X1. So 27.4 minus 8.2 over 2016 minus 2009. All right, we're going to get our trusty calculator and figure this out. 27.4 minus 8.2. Enter. That's going to be 19.2 over 2016 minus 2009 is 7. Now I divide. Here I have a very long, obnoxious decimal. But here they're blue here. Here the blue instructions tell us type an integer or a decimal rounded to 2 decimal places. Very good. I'm going to copy this decimal and we'll talk about rounding. Rounding is a very important skill. All right, if we want to round to 2 decimal places, here's the first decimal place, here's the second decimal place, here's the third decimal place. What I do is I look at the third decimal place and I ask myself if this 2 is big enough to round the 4 up to a 5. It's not. So I just drop these decimal places and make my answer 2.74. And does that mean $2.74? No, it means $2.74 billion per year. It's quite a lot. 2.74. They provide the dollar sign. They provide the billion. all you have to do is type 2.74. Now, this one is hard. It's hard because you have so many long numbers. You have to be so careful to not hit even one wrong little digit. Let's read the problem. The table lists data regarding the average salaries of several professional athletes in the years 1991 and 2001. And then here's a table over here. In 1991, the average salary was $266,000 per year. Right, average salaries. In 2001, the average salary had gone up to $1,410,000. So it says use the data points to find a linear function that fits the data. In other words, a linear function is y equals mx plus b. And instead of y, they're using s of x. And here's their answer. Let's try to get their answer. Now remember, the first thing you do when you're given two sets of data and you have to find the whole equation of the line, the first thing you do is you find the slope. Then you find the equation of the line. So let's start A with finding the slope. Let's let 1991 be x1 and 2001 be x2. 266,000 is y1 and 1,410,000 is y2. So m, the slope, is going to be 1, 4, 1, 0, 0, 0, 0, divided by 2, 6, 6, 0, 0, 0. Now let's see how they want this. Let x be the number of years since 1990, and let s equal the average salary x from 1990. Let s equal the average salary x years from 1990. Okay, now, right. That's totally wrong. Minus 266,000. Over. This is 1 year after 1990, which is what they're specifying here. Be nice if they had said that up here, but no, they waited to say it down here. This is 1 year after 1990, and this is 11 years after 1990. As it is, I could have said 2001 minus 1991 is 10, or 11 minus 1 is 10, but let's do it their way. 11 minus 1. Now, 1, 4, 1, 0, 0, 0, 0, minus 2, 6, 6, 0, 0, 0. That's 1, 1, 4, 4, 0, 0, 0 over 10. which makes this 10 will cancel out one of those zeros. 1, 1, 4, 4, 0, 0. Let's see if they agree. 1, 1, 4, 4, 0, 0. Yes. That's our slope, our rate of change. Now, I'm going to say y minus y1 equals m times x minus x1. So for y1 and x1, I'm going to take 266,001. All right, so y minus 266,000 equals 114,400 times x minus 1. Now, y minus 266,000 is going to equal, I'm going to distribute, boom, boom, is going to equal 114,400 x minus 114,400. We're not done. We have to solve for y. Now I'm going to add 266,000 over here. All right, now I start out with negative 114,400, and I add 266,000. Y equals 114,400 x plus 151,600. Let's see if MyMathLab agrees. 151,600, yes. 114,400x, yes, yes. All right, this is our equation, and we can use this to solve the other two questions. Namely, use this function that we've just come up with to predict the average salary in 2005 and in 2010. Okay. 2005 and 2010. All right, now X equals the number of years after 1990. So in the year 2005, we're going to have X is going to equal, I should have written that. X equals 2005 minus 1990. And that's going to be 15. So we will calculate y equals 114,400 times 15. plus 151,600. Let's put that in the calculator. 114,400 times 15 plus 151,600. And here's what I get. Y equals 1,867,600. Average salary in 2005. Let's see if they agree. 186. Yay, yay, yay. I love it. All right, now we're going for 2010. X will just be 5 years more, but let's stick to it. Let's be careful. 2010 minus 1990 is 20. So we'll have Y equals 114,400 times 20 plus 151,600. So we'll have 114,400 times 20 plus 151,600. I can delete. Let me show you what I did. I just put an extra 0 in. I can use my left arrow key to backtrack over that last 0 and then hit delete. And it's gone. Now I'll hit enter. And I get 2,439,600. Yes, and they agree. Not that MyMathLab can't be wrong. Always remember, and I've caught them at it, MyMathLab can be wrong. Why? Because it's programmed by human beings, and sometimes human beings make mistakes. Don't we all? That's why on exams 1, 2, and 3, you get to take it twice. Yeah, because you're human. The final exam you can only take once. But still, that's pretty good. Okay, now read what it asks you to do. Round to the nearest whole number. That means if there had been decimal places out here, we would have had to round to the whole number of dollars. And they're found on the left side of the decimal point. That's where the whole numbers are. So we would use the first decimal place on the right of the decimal point to say whether or not that 0 would round up to a 1. As it is, we didn't have to deal with any decimals. That makes me happy. Okay, here we have another one. Remember, you can always backtrack and watch the video again. In 1920, the record for a certain race was 46.2 seconds. In 1990, it was 45.5 seconds. Let R of t equal the record in the race and t equal the number of years since or after 1920. Find a function that fits the data. That means we have to find y equals mx plus b. Now, in 1920, and we're letting t, it's not going to be x. It's going to be t. Very, very often, you're going to be told to use t for time instead of x. They're almost always used interchangeably, where the x-axis becomes the t-axis, but it acts just like the x-axis. Okay, so this t is just going to act like x. Don't worry about it. Find a linear function that fits the data. Okay, now 1920 is how many years after 1920? It's 0 years after 1920. So in 1920, this is going to be our data point. Now, 1990 is 70 years after 1920. All right, so if this is x1, and this is y1, and this is x2, and this is y2, then for A, I need to leave it down here for a minute, then I'll scroll down. Well, yeah, okay. We'll have 45.5 minus 46.2. Can't believe people were faster in 1920. Maybe we're all slowing down. That's not true, though. You know that records are being broken all the time. Anyway, over 70 minus 0. So, clear. We'll have 45.5 minus 46.2. Enter. That'll be negative 0.7. Over 70 minus 0, which is 70. Now, look at your calculator. Down here on the lower right is your negative sign for negative numbers. Negative 0.7 divided by 70 is negative 0.01. So far, MyMathLab agrees with us. That's the slope. Now, remember I said that whenever you have a 0 for one of the coordinates in a point, it becomes much easier to find the equation of the line. In fact, if we're going to use y equals mt plus b, this is b, 46.2, because the y-intercept is the point you have when the x-coordinate is 0. Pretty cool. So, our equation is going to be negative 0.01 t plus Well, 46.2. 46.2. This is what we're going to use to find the other answers. Okay, now go back, 1920. T is the number of years after 1920, since 1920. So for instance, 1921 would be year 1. So let's see. The predicted record in 2003 and 2006. 2003. All right, we're going to have T equals 2003 minus 1920. 2003 minus 1920. That's 83. So y equals negative 0.01 times 83 plus 46.2. I believe this will be negative 0.83. I'm going to put it in the calculator to make sure. But that's my guess. Okay, negative 0.01 times 83 is negative 0.83 plus 46.2. So plus 46.2 will give us 45.37. Yep. Okay. Now, 2006. This is still part B. T is going to equal 2006 minus 1920. And that should be 86. So y is going to equal negative 0.01 times 86 plus 46.2. That'll be negative 0.86 plus 46.2. And that will be negative 0.86 plus 46.2, which is 45.34. One of the main reasons you find equations of lines and of other functions is so you can predict the future. Of course, there's a caveat there, a warning, and that is you have to make sure that all the important inputs, environmental factors, whether it's the economic environment or the natural environment, or the medical environment, whatever, you have to make sure that everything stays the same in order to make an accurate prediction for the future. And seldom does the world stay the same. So you've always got some error there. Now, finally, The predicted record is 45.20 seconds in the year what? We're supposed to find that answer. Well, Y is the predicted record. So C, I think that's C. C, yes. Find the year when the record will be 45.20. Well, here's our equation. Our formula, really. Negative 0.01 times t plus 46.2. And we're being told, okay, when is the record going to be 45.20 or 45.2? They're the same thing. Okay. Now, I'm going to subtract 46.2 from both sides of the equation. And that should give me negative 1.0. (46.2 minus 46.2 is 0. So I'm left with negative 0.01 t over on the right side of the equation. So here's what I've got. Negative 1.0 equals negative 0.01 t. Now I divide both sides of the equation by negative 0.01. Cancels out over here, leaving me with t on the right. And over here, 1.0 divided by 0.01. Negative divided by negative is positive. So 1 divided by 0.01 is 100. Okay, now, it's not going to be the year 100. That was a very long time ago. Now, what we're going to do is, since t is the years after 1920, this year is going to be 1920 plus t. So that'll be 1920 plus 100. That'll be 2020. Right there. Okay, notice, now this is just something I do, you don't have to do it. I've got a plus and a t right next to each other. The question is, how can I tell the difference between them? And the answer is I always put a curl on my t's, but I don't put a curl on my pluses. That helps me know the difference. So, okay, you can go backwards. You can rerun this video and watch exactly what we did and why we did it to help you understand. Of course, these notes are going to be in the modules also, in the week 1 module. Okay, I think this is the last one, yes. In 1990, the life expectancy of males in a certain country was 72.8 years. In 1996, it was 75 years. Congratulations, males. You all lived a few years longer. Let E represent life expectancy in year T, and let T represent the number of years since or after 1990. Okay, so when we start out in 1990, which is year 0, the very beginning, the life expectancy of males in a certain country was 72.8. Then in 1996, which would be year 6, the life expectancy was 75 years. Now we're being asked first to find a function that represents this measured fact. All right, so I'll let this be x1, y1, and x2, y2. So m equals y2 minus y1 over x2 minus x1. And that'll be 75 minus 72.8 over 6 minus 0. So 75 minus 72.8, enter, is 2.2 over 6. And 2.2 divided by 6 is that, which is, let's math bracket, 11/30. However, I'm looking at this, and it says round to the nearest 10th. So, I take this back, and okay. I copy this decimal. Now, if we're being asked to round this to 1 decimal place, there's the first decimal place right there. So I look over at the second decimal place, and that 6 will cause the 3 to round up to a 4. So this is going to be about 0.4, or the way they write it here is 0.4. So for y equals mx plus b, we're going to have 0.4. Is this x or t? T. Yes. Stop it. Go away. All right. Now, where was I? 0.4t plus 72.8. I can do that because the first coordinate is a 0, which makes this the y-intercept. That's the only reason I can do that. Now that I have a function that I can use to predict, we're being asked to use the function to predict life expectancy of males in 2008. Well, 1990 is year 0. It's the very beginning. So 2008 is going to give us t equals 2008 minus 1990. I wrote 2009, didn't I? Isn't that strange? 2008. Okay, 2008 minus 1990. Enter. Is 18. So t is going to equal 18. So y is going to equal 0.4 times 18 plus 72.8. 0.0, no, it's 0.4, clear. 0.4 times 18 plus 72.8. 80. Use a function to predict life expectancy of males in 2008. Well, here, y is the life expectancy. So y'all males are going to live until you're 80 years old. Imagine that. May you live much longer. This is it for the homework. I'm wrapping up the week 1 homework a week before the semester starts, and you'll be able to find this in modules. Week 1 module in particular. Okay, talk to you later. Bye-bye.